Okay, welcome to session 7. We have our lovely recap, which is obviously getting bigger and bigger. Please don't skip it. Every single time you're practicing and repeating, you are forming a deeper and better memory so that when you do need to recall it, you are doing it no problem whatsoever. Because they are getting bigger, they might feel like a bit of a session just in themselves now. And if that's how you feel, then always take a break before you go into that new learning. You're on a sort of self-paced study course, aren't you? Which means that you've got that control, so you should be able to do that. So I want you to hit pause and press play when you're ready. Okay, so let's get our answers up. Here we go. Okay, and again, with the answers, guys, I would hit pause and press play once you've had a good look through all those different workings out. You can see I've highlighted one. That one might have been particularly tricky, and I'll talk about that one when you finish doing your main marking, all right? Okay, so just really quickly pointing out a couple of things here. This one might have thrown you a little bit. This is something that we actually did in our grade 2 course. And if you haven't seen this for a while or before, then you may have struggled a little bit. And you'll notice that I've put in this kind of, they're the steps that we would take to solve this type of question. So it's divide by the bottom, 32 divided by 8, and then times by the top. So 32 divided by 8 is 4, and 4 times 3 is 12. And it's a really great way, actually, of being able to deal with that fraction. I think because we've done fractions as a big topic, this is a skill, like I say, developed in grade 2. But if you didn't do grade 2 and you haven't seen this, then you might be a bit like, what's going on? You could also, because it absolutely works both ways, is you could put the 32 over 1. We've learned how to do that. And then you can just multiply along the top, multiply along the bottom, and do your cancelling at the end. So there's 2 options to that style of question. And really, we're looking to use the most efficient method whenever we do maths. So it's good to know that there is a choice. Okay, so what else before we get into that green question? Obviously, I had to adapt the Chinese grid. I couldn't do my basic stock 3 by 3 because obviously I had 4 digits here. So then I just designed one that would work. And then once I'd done that, it was really super quick to just get through and do the maths that was required on that. Okay, let's get on, I think, to the green. Now, ratio is hard and it's our new learning. So if you found any of the ratio a little bit difficult, I do hope you looked up through your notes to try and help you. Obviously, the repetition, the fact that you're going to get to see and practice it lots and lots will be helping you as well. So if you're feeling a little bit uncomfortable with it at the moment, don't worry, that's quite normal. We are learning something new, and learning something new is always hard at the beginning. All right, so let's take a look at the green question. Now, it's technically not really grade 3. We're going up into the grade 4s with this style of question, and even they can go up all the way to your grade 5 at foundation level. They're really common, so they're something that we want to be exposed to. I've included it in this course because I think it's important. I think it's important that you're not capped, and that you can see the progression of some of the stuff that we're learning. We've already got all the skills to do this. It's just wordy and different. So let's do this question. So there are 600 pupils in a school and a quarter of them are in year 9. So this is saying a quarter of year 9 of 600 people in the school are in year 9. So that whole sentence can be written like that as that piece of maths. Now, to find a quarter of something, of means times in maths. And now you've got options. You could stick it over 1 and use your multiply and fractions rule. You could divide by the bottom times by the top. As it's a quarter, you can just half it again. So 300, 150. So I know that 150 are in year 9. Year 10 and year 11 are in a ratio. So year 10 and year 11 are in a ratio of 4 to 5. And I need to work out how many students are in year 11. Well, before I can do that, I need to work out the total that are in year 10 and year 11. I know there's 600 in the whole school, 150 are year 9. So if I take that 150 off, that would leave me 450. So the total of year 10 to year 11 in the ratio is 9. In the story, it's 450. And now I just do, how do I get from 9 to 450? I'm going to times by 50. So I'm going to do the same this side. And again, because I want to be efficient, I'm going to think about the question. The question just wants to know how many students are in year 11. So really, I only need to focus in on this part here. So 5 times 50 is 250. And as I say, I'm going to be doing things like this. I think it's really, really important to develop you and to develop your skills. If you got that right, if you worked through that and got to 250, the first time we've seen anything like it, then that is actually quite amazing. So really, really well done. If not, just take your time to think about what we've just gone through and and get ready for it. We're going to see it again. Okay, so we are going to do something brand new now. Okay, so we're going to learn a method called boxes and labels. This method is all about helping us solve questions that are directly proportional. Okay, and that sounds complicated in itself, doesn't it? It's very simple. It basically just means that when something is directly proportional, it means that it's growing at the same rate together. So let's give the example of buying a pen. Okay, so one pen might cost a couple of pounds. Well, if I buy 2, it's going to cost 4. If I buy 3, it's going to cost 6. And that's growing at the same rate together. Okay, buying litres of petrol for the car. As the litres go up, the price goes up. And they're connected, they grow together. And there's so many topics in maths where this happens, loads of topics. You wouldn't believe how many. But what I have found over the years is that students just don't quite know how the numbers fit together. So in order to support that, I came up with this boxes and labels method, and it works in so many topics. If you can nail this method, and then the next job obviously is to start recognizing when you can use it, because that's a big part of it as well. When you've got all of that package, if you like, you have just increased the number of marks that you can get on your GCSE by a huge number. So this is powerful. This is really good stuff. What we're going to do in today's session is just learn about the box. So you can see there's no labels on those boxes. That's what the box looks like. So it looks a bit like a smashed window. The numbers come from the question. So whatever the question's story is, there'll be some numbers, and I populate them into the box based on the labeling, which we will do a little bit of today. Not going to go massive on that today, because I just want us to understand the first step of this method and not try and load you up with too much information. Okay, so it's all about something we call a multiplicative relationship. Again, another thing that sounds complicated. You don't need to worry about it. Multiplicative relationship means kind of what it sounds like: multiplicative, multiply. The times tables, it's all about what we multiply to make things. So if I look at this first box, on this side, I've got 2 pieces of information, but on this side, I've got a piece missing. So this side is going to help me. It's very, very much like the ratios we've seen, like virtually the same, just with a box around it. 4 times 5 is 20. So 5 times 5 is 25. So the missing number in that box is 25. And that's it. 8 times 4 is 32. So I'm going to times this side by 4. And I've got 12. Job done. So what I want you to do is just hit that pause button, finish the last 4, and hit play when you have finished. And these are the answers, guys. Okay, and you will see that I'm looking at what I times by, okay? But sometimes I'm going to do the opposite to help me with that different number. So here I could see I got a times by 3 to get to the 9, but I've already got the big number here. So I'm going to do the opposite and divide to find the smaller number. And I hope you worked that out, because I didn't show you it, did I? Which I did on purpose, as I'm a horrible person. All right, got to get our brains all warmed up, ready for today. Okay, so again, that needed a backward step, so I did a divide. All right. So that's the box in its basic, most simplest kind of format, if you like. The easiest way for me to demonstrate it to you. All right. If we look at these 3 boxes, and we try and do what we've just been doing, you will see that that is not easy. 2 times something is 2.2. And if I haven't got a calculator, that is not easy. But this is why I love the box, because the box doesn't just work going downwards, it works going across as well. So if I haven't got a good one this way, I can look that way and I can see that that is times by 5. So I need to times that by 5. Okay, so 2.2 times 5. I mean, if you didn't have a calculator, then you would just set it out and work it out as a sum, maybe in a column method or whatever. But I'm quite fine with calculators if you're feeling that the maths isn't quite so easy to do by hand, because I want you completely focused on the box and the method and how you use it, because that's the first thing to secure. Once we're confident with the box, we can start learning how we can use it all over our GCSE. Okay, so do the last 2 and hit play when you're ready. Okay, so 6 times 3, so 2 times 3 is 6. I need to do 7 times 2 to get to that 14. Doesn't matter that I'm kind of going in the opposite way, it's still multiplying by 2. So do the same here, 2 times 2, and you've got 4 as your final answer. So if the numbers are nice and they're in our times tables, then we can just use those to fill in any missing numbers in the box. But some questions are not nice. There is no way, even if I go down or across, that I'm going to be able to do this easily by hand. Yeah, 5 times something is 12, but I don't know what it is. And 5 times something is 32, but I don't know what that is. So this is where we need to know a little bit more about the box in order to make it work for us. Because actually, more often than not, the numbers aren't in their times tables, and it will look like this, okay? So this is what we do. We, first of all, check to see if our tables will work. Once we've decided that it won't work, we have to look for what we call the trapped number. And I'm going to highlight the trapped number. It's that one there, and then explain why I call it trapped. So if you remember the little puzzle game where you've got the tiles and you have to slide into the space, and then you move things around until you've put them in order. Maybe it's the alphabet that you're putting in order, whatever. But if you remember that game and then look at this box, it could be that game. And the 5 can't go anywhere yet. The 12 could slide into this space here, or the 32 could come down into this space. But you can't slide the 5 at all. It's trapped. So I call that my trap number. And the trap number is the number. So when I start organizing these numbers into a piece of maths, okay, the 5, the trap number, is going on the bottom of a fraction that I'm in the middle of making, okay? So that is what I write. I locate the trap and boom, write it as a denominator. Then these numbers, 12 and 32, are set up like that, okay? It doesn't actually matter which way round I do that. If I was to do 32 over 5 and times that by 12, I will get the exact same answer. Exactly. So that step isn't so important. What is absolutely essential is we get the divide by 5 right. We get the denominator right, because the other bit doesn't matter. And then you will literally throw that into a calculator, which I have handy. And I've got the answer, 76.8. Okay. 76.8 is the missing number here. And it is the answer to whatever question those numbers came from. All right. So let's have a little look. We've got 6 written, ready to go. I am going to do the first one so that you've had another talk through. If you don't think you need that though, then feel free to just pause from now and start having a go at all 6. But if you're thinking, no, I'd quite like to hear that and see it one more time, then just let it play. Okay, so the first thing I'm going to do is look to see whether or not a times table will work. It won't, because I've deliberately written questions that won't, but I've got to know that's my process. Then I'm going to just pop a circle, because I'm not always going to have a highlighter handy. I'm going to pop a circle around the trap number, and my first job is done. The numbers can then go in any order. And then I am going to throw that in my calculator. So I've got 32.5 as my final answer on that one. Okay, so try not to overcomplicate this, just locate the trap, stick it as the denominator, and boom, set up the rest of it. Calculator does the work. All right, so pause, give those last 5 a try, and then hit play when you are ready. Okay, there we have the answers. So mark up, make sure you are happy with that. And that's it. That really is it, okay? So that's how the box works. The hard bit is applying it. It's realizing, oh, this question here works in a boxes and labels structure. So that's one of the things that we're going to be learning, trying to work out how to identify it. One of the things that I say to my students is, when you're absolutely stuck, you're reading a question, I don't know, I just don't know what they want me to do. We all feel like that sometimes. When you're reading a question like that, what I want you to do is just have a really good look and think, are there just 3 pieces of information? Because if there are 3 pieces of information and you've got to work something out, that is one of the things boxes and labels is. So it's 3 pieces of information that go into a box, isn't it? And those 3 pieces of information are set up in a calculation to find me my missing number. So if you do have that situation, that feeling of, oh my God, I don't know what to do. All right, then we're going to train ourselves up to think, right, can I use it? Even if it might not work, but at least you're trying something. Okay. And sometimes genuinely it does. It's like magic. Okay. So this is a question that we saw previously, and the reason that I brought it back is because it actually is a boxes and labels question. We don't need it, okay? And there will be times sometimes we think, well, I don't need boxes and labels for this. I know what I'm doing, and that's absolutely fine. But we want something for when we're stuck, and this is what this is all about. So let me just show you how this works with our boxes and labels. You would have written these on top of each other, and as soon as I do that, you can see 3 pieces of information. I need to find the fourth. So when I'm reading this, I've got 1, 2, 3 numbers. 3 pieces of information helps me find the fourth. So if I wanted to, I could just stick that in my boxes labels and look for a connection. There is a connection this way. I can times by 14, which means I can times by 14 and n is equal to 14. I could have said there's a connection this way. If I divide by 5, I can go down. So if I divide by 5, the arrows are going the same way. So do the same thing, divide by 5. So the boxes work here. And that is an important thing to realize about ratio. There are actually only 2 methods when it comes to ratio. Ratio will be hard for a long time. It really does take a lot of practice to get good at ratio, but there are only 2 methods. They either fit into boxes and labels or they go to invisible column. So if I've got a question where I can't set it up like this, then it automatically goes to invisible column. And that's the 2 methods for ratio. Any ratio question works like that, okay? So that's that question. And we also saw this one. So this was another one where it works with the ratio. So Ellie and Frank, okay, I've got Ellie and Frank. They share apples in the ratio 5 to 2. Ellie has 40. They're making it clear Ellie has 40. So 40 goes into Ellie's column. And there it is. There's my box. And it even has a label. So that's how the labels appear in the method boxes and labels. There will be something in the story that makes the labeling work. And again, we will build our skills in this. And then I will just use what I know. 4 times something, 5 times something even is 40, which is 8. And 2 times 8 is 16. So we've already been seeing a piece of maths where we could apply this boxes and labels idea if we wanted to. So that is just making you aware of it, really, more than anything else. Okay, so we're going to finish off by using the method for best buy questions. Best buy questions are really, really common, very common on the calculator paper. And like I said, you may be quite good at these and think, well, I've never used boxes and labels before. I don't need it. Don't use it then. I'm trying to give you something for when you are stuck, okay? And I wanted to show you the versatility of this method by showing you lots of different topic areas over the courses, okay? So let's write a question. I'm gonna not write masses because we don't want to wait around too long. So let's say 5 bags of crisps cost £4.50. And 8 bags of crisps, don't know if they're multi-packs or not at that price, are going to be £8.80. And the question is, which one is the better value? Which one should you go and buy? Because the actual individual bags of crisps are better value. So this one is, I've got 2 pieces of information, not 3. So it's not as obvious that our boxes and labels would work a treat, but I need to be able to compare these. So if I just knew what 1 bag cost in this scenario and just what 1 bag cost in that scenario, then I would be able to make a decent comparison and I wouldn't just be guessing. So that is like my 3rd number. So let's look at the first one. Okay, I know that 5 bags of crisps, so I'm going to label it C for crisps, cost £4.50, and I'm going to put in my pound sign. And I do that because I don't want the next number I put in to go into the wrong column. If it goes into the wrong column, it's not going to help me get the answer. So when there's a story, like here, 5 bags of crisps costing £4.50, that 5 and that £4.50, they're connected. They are a fact. And that connected pair, that are the fact in the story, always goes side by side in the boxes and labels. Now, don't worry if it all feels a little confusing. I promise you it's because it's new, not because you can't do it. All right. I want to know what one bag costs. Okay. And I'm just going to use my trap number method. I'm not going to try and do it by hand. These questions are incredibly common on actual calculator papers, and that's how we're going to learn it. We're going to let the calculator do the work so we can just concentrate on where we are putting all the information so that we get really good at getting it in the right place. So that's my trap number. So that's straight away going on the bottom. I'm going to pop it that way round. Doesn't matter, remember which way round. Grab my calculator, make sure I put it in properly, and I'm getting 90 pence. So my calculator actually said 0.9, but I know that that would be 90p. Okay. So that's the first one compared, well, got down to the cost of 90p. Now I'm going to repeat the whole process with the other information. So they are being treated separately. I'm not combining the numbers. They are in separate sums. So this time I've got 8 bags for £8.80, and I just want to know what one costs. So I've got my crisps, 8 bags, £8.80, squash it in there. I want to know what one packet of crisps costs. So this time it's going to be that piece of maths. So that is giving me, oh, just looking at my calculator, I hit something wrong. I was thinking, it can't give me that. That's not right. Let's try that again. That's more like it. So that's coming out at £1.10. My calculator gave me 1.1, which I know would transfer into money is £1.10. Okay. So actually, value for money wise, it's cheaper per packet if I buy 5 bags than if I buy 8 bags. And this is actually a really important life skill, because this is the type of things that supermarkets do. They give us offers all the time. And we always assume that the supermarket is set it up to give us the best deal. The best deal usually is the more you buy, the cheaper it is. And they prey on that. They will go, okay, that's what our consumers, that's what our customers think. And we'll do it most of the time so that it's a really, natural thing for them to think. And then every now and again, we won't do it. And they'll just automatically pick up the biggest lot because they think they're getting value for money when they're not. So this is a brilliant life skill for us to have. If we're going to be spending a fair amount of money on something, we want to make sure that we're getting the best deal possible. All right. And always, always looking for the cost of one in this type of question is the easiest approach. There are other ways to do it. You can multiply up and match the same number of bags, but there's usually a lot more steps involved if you do it that way. And it's just open to more error. So just find out the cost of one and boom, job done. Let's do that again so you see it one more time. And then I've got a few little practice questions for you. Okay, so we've got 12 loo rolls. They love loo rolls in the exams, don't they? So 12 loo rolls cost £8. And we'll say that 9 loo rolls cost £6.48. Which pack is the best value for money? So I want you to hit that pause button this time and have a go. Just have a go and see how far you get. And then I'll talk you through it. You can hit play when you're ready. Okay, so let's do the first one. So I've got 12. I'm going to do L for loo rolls. Got my pound sign, £8. I want to know the cost of one. So I've got 12 trapped. I do like a circle there. It's really good because it just focuses in again on what it is you're supposed to be doing. I'm going to times that by 8. So hopefully put it in the calculator this time and not freak myself out. That's good. Okay, so this is coming out not perfect money. It's coming out with that recurring decimal. So I'm going to round it based on money. So 67, so 67 pence, let's say. And then I can crack on with the next one. So it's loo rolls in pounds. This time I've got 9 for £6.48. I want to know just the cost of one. So that's going to be my trap number. So 9 is on the bottom. And away we go. So and I've got a funny on and on it goes situation. Change that and it's 71 pence. So looking at the two answers, this one is definitely the cheaper one. So the 12 loo rolls are the best value and that's what I should buy. And that is an example of us seeing what we expect. We expect the more we buy, okay, the cheaper it is. And it is in that case by about 4p a roll, okay? So those are the examples. I would like you to have a go at these questions. I haven't done loads because we've done quite a lot just getting into the method itself. So there's 5 questions there. I want you to do the normal thing. I want you to pause, have a go at the first question, hit play so that the answers roll up, mark, and then you do your rewind, play, do it question by question. And then I will obviously catch up with you in our next session. So hit pause and press play when you're ready. Okay, so to fit the answers in, I'm just going to downsize it a little bit. Has that got them all in, or do I need to go a bit further? Go a little bit further, I think. There we go. Get rid of me, don't need me. Okay.